This episode of This Agile Life has been brought to you by BrilliantAgile.com, providing Agile and Scrum training, consultancy, and personnel.
BrilliantAgile.com. Done right, it's brilliant.
Released on Sunday, March 22nd, 2015, This Agile Life, Episode 77, Sniffleupagus.
The software industry transforms more and more every day. Agile methods are quickly replacing traditional ones. The question is, are you agile enough? This podcast is devoted to agile and lean software development. Time to welcome your agile coaches on This Agile Life.
Hello, everyone. I'm the host of This Agile Life, John Sextro. Joining me today, I have two great co-hosts. First up, Craig Buchek. Craig, how are you?
Doing great.
Glad to have you on the show tonight. Also with us, Craig, we have Amos King.
Yay! I'm so happy to be here.
Well, we're happy to have you, Amos.
I took some medicine so that my nose wouldn't sound all clogged up. Let's hope that it stays good through the show. If I start to taper off towards the end, everybody will know why.
As soon as you start to sound clogged, we'll just wrap it.
That sounds good.
5 minutes in or 50, whatever happens. All right, tonight, this episode, we're going to be talking about hardware, infrastructure stuff, dealing with hardware in an Agile project. Guys, I happen to have some personal experience here. I have some, in the past, been working with teams, and we've had just straight up had struggles with figuring out how to incorporate working and dealing with hardware and infrastructure onto our teams. And as I'm sure you're aware, there's a new trend these days called DevOps. So maybe we'll talk a little bit about how DevOps fits in, and just overall talk about how to deal with getting hardware set up and working that stuff to integrate that into your Agile process. I guess the biggest thing that I have experienced problems with, guys, and see if you have any insights in this area, is that you're building software, and software is so very malleable. There are very few requirements that you need other than a computer there that you're going to be working on to create that software, that you can just get started with it. There's a very low barrier of entry. There's low friction to getting started. However, when you're depending on some amount of infrastructure, and this can be nearly anything, because at some point you're going to have to take your software and put it onto hardware somewhere, right? Whether it be a database server somewhere that you need to get set up, or if you're developing software for firmware, or you're developing firmware for hardware or software that's going to run on custom hardware, there's just some amount of stuff you have to deal with. So what can you do to incorporate and bring the hardware work into an Agile team?
Well, my first question is, are the people working on deploying this hardware a part of your team, and can they become part of your team?
Yeah, I think let's set an assumption there for our conversation and say that yes, we have people on the team that are skilled with deploying the hardware, are skilled with setting up the hardware, they're skilled with configuring the hardware, etc. However, there may be circumstances where they're deploying this hardware into the field in places, and they are unable to physically put their hands on those systems because they're going into client data centers, or they're going into secured locations, etc., right? So you kind of have to just send that work out into the world, assuming that at some date it's going to be done and that you're going to get your hands back on it.
So is that the part that you've struggled most with, the part that's outside of your team?
Right. That's really the hard part, is dealing with something where it's really outside of your control, and you kind of create some sort of a work request, and it goes off into the ether, and you have very little control over the people that are going to do that work. and then at some point it comes back to you, and that there's nothing that you can change about that. It's just life. You can't have those people on your team, and you can't necessarily you can't affect their schedule and their work schedule, their work processes, because it's outside of the scope of what you're doing. It's like an external dependency.
Yeah, I mean, even like traditional. Well, what I understand is DevOps is a lot of like deployment scripts and setting up the server, but not physically like plugging in a server and moving it around. So is that what we're talking about? Is like the traditional like configuring all the software, or are you talking about like plugging in racks and setting everything up?
I think for the sake of our example, we're talking about getting any long run. Let me, maybe I can genericize this in a way that we can just attack and say it's some sort of external work that I can't directly control, right? It could be really anything. There's this team has an external dependency on stuff happening. Maybe it's at some third party vendor, or I guess a third party vendor is the best example, where I can't control them. We rely on them for this thing, and I just have to deal with it.
Yeah, that sounds like the more general problem that we run into in more than just the hardware installation case. I've run into it for deployments. You have to schedule with external teams and deal with their schedule.
So how can we better work with these external dependencies?
That's hard. So if they're a service, like let's say you hire a cloud company that has some VM setups and stuff for you. If they're not responding fast enough, I say go find a new one. But
even if they, all right, forget that though. Even if they respond really quickly, okay, there's always going to be something that you have a dependency on that you can't necessarily control. It just so happens that in the example I was using, it was hardware, but it could be anything. It could be hardware
approval from some certification organization that's required by law.
There you go. That's another example.
Getting an SSL certificate.
The required by law certification is a little hard to get around. You can't replace that one. I mean, Amos is right. If you're, in a lot of cases, in almost all cases, I would think, you can sort of get around that by, okay, your hardware is too slow to get provisioned. Well, go provision it. Find someone else to provision it that's faster.
Right. I was just trying to get the easy case out of the way.
Yeah.
Love fruit.
Yeah. There are opportunities for that, and you might have to think outside the box. If your business is running data centers, then maybe you can't really outsource that component, though.
So one thing that I've had that works really well is whenever I have something that can't wait, like I need it done as quickly as possible, is the same thing for them that I would let customers do with me is shorten that feedback cycle, right? That's what we want to do. So when they're working on that hardware for you, get on the phone and stay on the phone with them and talk to them and work through it so that whenever they have questions, everything is answered immediately. So that's one of the good things, is to provide them the same types of feedback that you wish you were getting.
So shorten the feedback cycle means tell them right when you need it instead of a week ahead of time, right?
No.
Oh, okay. Just checking.
But what I mean is, whenever you tell them, then sit there with them, stay online, be like, hey, I'm here in case you have any questions. And if we need to schedule this time for 2 hours from now or whatever, that's great. But let's get a time when we can both be here so that we're not going back and forth on email and taking a day for every question.
What if it's a situation where that thing is in a cave somewhere, it's buried in the stacks of a server room, and there's no phone reception? It's like, somebody's got to endeavor out into that area. They can't get any cell phone service in there. It's basically a Faraday cage,
Yeah, not allowed to take their laptop in and be online or anything like that.
Yeah, they got to go rack and stack some equipment. It's going to take them a bunch of time, and they may have to come back to you for, I don't know, IP addresses or port addresses or.
Yeah, I mean, it's the same thing that I have whenever I work on my house, right? I got to make 8 trips to the hardware store because I never have everything I need when I get down under my sink.
So, all right. So that tells me a few things. One, we need better tracking of what we're doing. We need better preparation. We need, checklists. I think I've talked about checklists before. Amos apparently needs a grocery list when he goes to the hardware store.
Oh, I get a list. I just sometimes don't know everything that I need up front, right?
And this is true, and this is true in projects as well. You could spend a long time coming up with your list and just not have anticipated something that they needed.
Right, you're gonna have that happen. One thing that I've done is set up the same kind of system locally. Maybe smaller. Like if they have 30 servers, I might do it with 4 or something like that, like way smaller, but something I can manage, and then go through it myself and document every single little thing that I'm doing and try to hand that to them and say, look, I've done this on a smaller scale, so maybe some of this can help you. And they can look at that before they go down to that server room and also come back with any questions immediately.
Yeah, so you've jumped to the kind of to the end of this whole thing, at least in the way I was thinking of it, because that happens to be exactly what I have done in the past in these cases, and with hardware especially, is anytime we have some sort of an external dependency on hardware, we need hardware like this, it looks like this, it's all this stuff external in some place. I submit tickets to get it all created, spun up, and all that stuff. Then what we need to do is create that exact environment, or a facsimile, a small scale facsimile of that environment that I can control, that we can control as a team.
If you have repeated slices, like a lot of web projects, you have repeated slices, right? You have like multiple copies of a database, multiple copies of an application server, load balanced. If you can do like 2 of those slices load balanced, then you have a pretty good structure to go by of like, this is what I need. I just need 10 more of these. And like, I think that's a big thing of why tools like Docker are created, is because at least you can have everything except for the hardware piece together, and then they can just drop those in VMs.
Right. So Docker is the idea is basically standardized shipping containers for software. So before they had standardized shipping containers for overseas shipping, it was hard to manage sending products overseas. But once they standardized on a shipping container that's the standard size as everyone else's, now they can stack them, they can pull them off. It's really easy to ship a container full of anything. Doesn't really matter what it is. So the idea is to do that with software. That's what Docker's idea is. So Docker is one of those DevOps things that people just went crazy over as soon as it came out. Some of the other things are like provisioning software on an operating system. Things like Chef and Puppet and Ansible is my favorite of those. Those are going to get a lot of ground and in the DevOps community. And the idea is to be able to deploy a server in a couple minutes, to provision a VM, to deploy an operating system, to configure that operating system, and to install the software all in preferably, less than a minute if you can.
Well, and then you've brought that feedback cycle internal to the team,
right,
to your team. And so they build all the software, all the configuration, everything, your entire box except for hardware. And then you hand that off to the team that's going to be installing that on a server.
Right. And so actually your operating system configuration and all that stuff is actually checked into your repository. So you've actually got that in version control, and you maintain the DevOps scripts, I guess I'll call them, that gets a server deployed.
So this is good, because this is exactly what I wanted to get into. And this is what I think we want to get to eventually. with DevOps is doing this. But one of the things now that we have before we can build these scripts, before we can write the configuration scripts, one of the things that we're going to need to do, we're going to build a small scale version of what I'm going to deploy massively into data centers around the world. Okay, we've got plans to put this thing in 7 data centers on 7 continents. Okay, even though I don't know that there's any data centers in Antarctica. But
I bet there's at least one.
I just built
probably
one.
Only one
the other day. I launched it there on my yacht. But
nice.
So now we've got to build in our area, in our room. We've got a room somewhere right near the team area, let's say, and we're gonna go build this thing. It's going to be a rack, and it's going to have some networking gear in it. It's going to have some server gear in it. It's going to have power gear in it, and whatever else all goes. I don't know, Craig, maybe you can come up with some other stuff that would be in this rack. But we're going to build this rack of equipment. Literally. I mean, these guys are going to literally, our team is going to literally go in there and they're going to build this stuff. So how can I split that work up in a way that allows us some flexibility and some agility?
I think for the most part, you do it the same way as everything else we're doing. You break it down into small pieces. You track it on Kanban across. I don't know if you'll need QA. Maybe it needs its own column.
Yeah, but I want to get into some of the specifics about how, right? How do I test stuff? Because when you're dealing with hardware, it's hard to do like a thin vertical slice. So what is the thin vertical slice? If I need cabling, networking gear, servers, as that's just the hardware, right?
I think the thin vertical slice is a single virtual machine or a single piece of hardware, a single server. But you're right. If you're racking, you actually, in some ways, the rack is the narrow slice. You need cooling and power and networking, and space planning. Yeah. So building this in a small scale, let's say all of that stuff could take, just for sake of argument, to have people do that uninterruptedly, it would take 3 engineer developer guys, a week and a half, let's say, to do all this stuff. They've got to build the gear, they've got to get it all in there and do all that work. So how am I going to track, create stories for that?
So could we set up a single rack with one database server in it and make sure that we can hit our database?
Yeah, I think you start with single pieces of hardware. A single server. You get it working, and then you move on to the next server. I think you do it by server.
Okay, this is how this is going to work now, because I think this is going to be fun. At least it's going to be fun for me. It probably will not be fun for you guys. Okay, you ask me those sorts of questions, and then what I'm going to do is put a constraint on it. Because this is what happens when I suggest these things as well to teams throughout my life. Can we put, so your question, Amos, was, can we put a database server in there and connect to it and make sure that it works, right? That was your question.
Right.
My answer is yes, but first I have to rack it, I have to get power to it, and I have to set up the networking gear.
All right. My first thought here is, why are you dealing with real hardware? It's 2015. We should only be dealing with VMs at this point.
What if you're working with the data center? Like, that is your job. You work at a data center.
Yeah, but even that should be abstracted from the development team.
So that was the part where I submit a ticket and it goes off into La La Land, and the cloud data center provider, they do all of that stuff. But what I'm saying is, let's assume for a second that I work for a cloud company and I'm creating a new cloud product. Okay, I am the cloud. Hear that, everyone out there in listening land? I am the cloud.
Don't rain on us.
I won't. Okay. Now we're creating a new part of the cloud. It's brand new. Nobody can do this yet because I just invented it. So we're over in the corner building this stuff for the very first time. We're figuring it out for the very first time. There's real engineering work going on here. We're figuring out how all this stuff works together. We've got to build it here in the small, prove it out, get our software on it, see how it works, and then we're going to send it out into the wild.
So in this case, the servers are sort of your data, not your infrastructure.
Interesting. They're data. Tell me more about that.
Well, because that's the things you have to work with. These are the things you're managing. If you're running the cloud, you're not. Those servers aren't what you're running on. Those servers are what you're providing as a service.
Yes, they are part of the overall service.
But you probably want to dog food them too.
Well, I need to figure out how to create them.
This is a weird problem when you are the data center that you're wanting to run on the things that you're writing the software to provision.
Yeah, I am the bare metal.
Chicken and egg problem.
Right, I am the bare metal. So that's why we're in this. That's why we're working small. We're working locally. We're taking the engineering effort and time to go through and figure this all out. So back to Amos's question is, I've got to get a server in there. I'm going to call it a database. You know, how do I go about making all of that happen? Because I've got to get power to it, network cabling to it, network gear to it. I've got to put software, a base level OS on there. I've got to put database, EBMS software on there.
Wait. You have listed out a bunch of stories to me. The very first one was we've got to get the rack down. All right, let's get the rack down. And we've got to get power up in the rack. Okay, that's number 2. Hey, have we got power? We can QA that. We got power? We have the right amount of power? Is it stable power or is it spiking all the time? Do we need to put a power filter on it? So now we've got that. Now
we have
next
cooling. What's the
temperature in there?
The temperature in there.
Is it when I put one now? We're up to putting a system in there. We plug it in. Is the temperature still stable? Is that system not overheating? Everything like that. Okay, now can I put a second one in there and have the same thing? Like these are all the little steps along the way.
So,
and as soon as you have a system running in there, you should be able to start hitting that while they're getting the next piece of hardware plugged in.
Those things that you're doing along the way, those almost seem like unit tests, right? You're going to say, the networking gear should be able to provide a network connection, and that's the unit test, and then you hook it up and you're able to test that the network gear is at least doing that, right? Same thing.
And I would say you can write automated tests for that.
If you're running exactly a data center, I would think that your power equipment actually is you can actually query it and see what, if my power is stable and if it's the right amount and probably what my draw is. Same with cooling. I would think every rack would have a system that tells me the temperature of that rack. So I think you could actually write automated unit tests for those or acceptance tests for those.
But all I want to do is get a small scale environment built to prove the creation of the environment. Because the data center does all that. I disagree with that.
Okay,
I just want a small scale app built to prove my entire app.
Well, if you're a data center, then you have to worry about all these things, right? That's fine. But that's not a small scale. If you're a small scale, there's no such thing as a small scale data center. If you're small scale, then you farm out the data center process and you just get a virtual machine and then you work from every layer up from that.
If you're building a data center, though, right? If you're building that hardware, you've got to start somewhere. And you need to test along the way to make sure that you've got what you're expecting.
But that wouldn't be something that a development team would be worried about.
Yeah, this is a cross-functional team of software developers, engineers that are building a fictitious product that's going to be forklifted into a fictitious data center for a fictitious company. Fictitiously.
I think this is coming from a place where we've all been, where we have some people doing the hardware setup, that are outside of us. and how do we manage
Right.
that and the time that it takes for them to do that? Like, are we just, because a lot of teams just sit around and wait for that.
So let me throw a different describe this in a different way and forget about the data center example for a second. Let's say we're building a new tablet or a new phone. Okay, we're coming up with the hardware in almost in parallel with when we're coming up with the software. So we've built a simulator to some extent, but now I want to, in an agile fashion, go and actually start building hardware to put the real software onto rather than just on the simulator. So I've got engineers and software developers working together side by side. They're figuring out how all this stuff is going to work together. What's the first story?
Yeah, you've seen the analogy of, instead of building a car with wheels, you give them 4 wheels, but that's not really a car. It's not going to go anywhere. And then you've got a chassis and wheels, but that's not a car. It doesn't have a steering wheel. And he doesn't get the car to the end, right?
Every day I do the skateboard.
And then the Agile
scooter,
is the skateboard to the scooter to the
bicycle to the.
But try building a real car like that. It doesn't work for hardware. You can't start out with a scooter and end up with a car. You have to actually build hardware in an assembly line. You can't build it, starting out with that scooter, because
you're right.
You're going to throw the scooter away. Hardware is different than software.
Hardware is hard, and that's why it's called hardware, and software is malleable, and that's why it's called software. But
it's harder.
You could start with. I'm not saying you're going to build an assembly line on day one to build skateboards, and then you upgrade the assembly line to build scooters, and then upgrade it again to build bicycles. What we're talking about is product development, where you're innovating. So you're coming up with a new product, and it's like, I know this isn't the final product, everybody. So what we're going to do is build something shitty that's held together with duct tape and baling wire and twine, right? We'll just zip tie it to the racks because this is not how it's going to be in the final state, right?
And that's what car manufacturers do.
And they build it shitty.
They build a concept car. Yeah. And even before you see a concept car at a show, they've probably already built 2 or 3 of them that are crap.
Or that are built out of balsa wood.
Right. Actually, they're built out of clay before that, usually, and they're built on a computer.
Yeah, a little small. Yeah.
Right.
So that's what we're saying with things like Docker, is you're building it on fake on the computer, and then you're going to go build a single rack that is your prototype of your stuff. And you can even start with pieces on that, right? You could, just like an assembly line, you could put the wheels on it first, which is your power. And then you can put it in.
No.
Why?
You can't do that.
Why can't you do that in your rack?
I mean, is that a thing? Is that a done thing, though? Or are we saying that that's a done thing? Because that's not a done thing if it just has some wheels on it, right?
No,
you're building towards the thing.
Wow.
Right.
Okay.
But you know what? When we talk about building software, we say we quality check all along the way, not just at the end, right?
Yeah.
So you're not going to check when that rack is completely done that you actually hooked up the power. You're going to check that as soon as you hook the power.
So I guess think of the rack as your thin vertical slice, and think of each step as a unit testable thing.
Right.
I agree. I think that's the way you do it. So you put the power in, you make sure the power's. That's your unit test for the power module. Then you put servers in there. You make sure that they boot. They've got nothing on them, right? But they're screwed in down and they work.
And honestly, I don't know that Agile techniques necessarily work. Lean and Kanban might work, but I don't know that Agile itself actually works.
Well, Agile is really just about feedback and changing, right?
Right.
So the less that you do before you test, the more that feedback you get, and the more possibility to change before moving forward. So
like in your iPad example, you're making a new iPad. Basically, the more you can find ways to make incremental change, the better off you're going to be. So that's why you have in-house prototypes that you can change the hardware every day. Maybe you're going to wire wrap some circuit, that was different than yesterday.
I play with hardware all the time. I start out on a breadboard.
Right. So you get, from breadboard and then you maybe make an in-house circuit, and then you
on board, and then you make
toward the end you have to outsource it, send it off for a month to get your beta prototype that actually that looks like what you want to do.
I mean, that's a good example, because like doing an Arduino project, you might be building this thing with, it's a kit. So you're trying stuff, you've got hardware, you've got software because you're using the Arduino software, right? And you're trying things. And if you're able to cobble together a prototype that is a real working, skateboard thing, then you maybe, like you said, Craig, you package that up, you document all that stuff, and you send it off to, a manufacturer who takes your design and turns it into the real deal piece of
So
product.
In your case, you're going to hand that off to your hardware data center guys and say, we built you one rack. And it's got all the hardware in it. And maybe you get some of those guys to work alongside your team. Like in your team area, you set up a rack. And that guy works with you side by side, getting everything the way it needs to go. And he knows how to deal with airflow and all that. So you've got that feedback going. And then when you get one rack built, you say, okay, this is what we need to replicate 100 times.
Yeah, if you're going to build 1,000 of them, then spending that time to figure out how to do a rack quicker and tested before it gets to production is probably worthwhile. If you're doing two, then probably not.
And I did all that rack stuff in communications when I was in the military, and there are software programs out there for doing layouts of a rack.
Sure, and all of the smart people know how to do all of the smart rack layout stuff, but it's just coming up with the configuration for everything, because things are new. You have to figure out how do these things work together, and how do we configure them, because you're the people that are creating this product. It's your job. It's your vision. You're creating this thing. There's other people, smart people, that know how to pull cables and do airflow stuff and all of that, power management. They know how to do all that stuff, but you just have to basically send them all of the stuff and say, we built this thing, here's in the small, right? Here's how the product works. Here's what the product is. We're sending you all the information, and then they basically sort of recreate what you created in a small scale in their environment. Like with the manufacturing example, you create a prototype, and then you send it out in the world to be manufactured.
And this is why Alan Kay says those who are serious about writing software should create their own hardware, so that know how that works. And then it's a lot simpler for you to.
Yeah, but the process is going to be a little more different than we're used to in software. It's a little more waterfall-y.
But you need to get the.
Some cases. The other thing that John was talking about is actually a troubleshooting. He was talking about, you've got this new piece of network gear, and you got to get it working, and you've never done it before, and it's
and
troubleshooting doesn't fit in the Kanban or Agile world very well either, actually.
Well, I don't think that it's more waterfall-y. Prototyping is not waterfall-y. You don't know. You can, no matter how much planning you do up front, you're gonna you can prototype Agile, and then you get your prototype done, and you send it off, and they send you the right one.
Right. Well, that's sort of the long pause in a process, which Kanban and Agile aren't very good with.
Your prototype is just your test for your final product.
I know, but it's that month when you send it out, your prototype to be manufactured at a real manufacturer, that you got to wait a month.
It just takes time.
That's the problem.
But
what do you do what do you do in that time, though? And how do you make sure that that's working right and going to get done on time? That's kind of what John's been asking.
Well, I think one of the things that's tougher is when you're doing some of this innovation work, where it's stuff that nobody in your group has ever done before, because it's this brand new thing, right? So you're trying stuff out. So that could be a case where you have a story that says, configure this piece of hardware. Nobody's ever configured it before in your group. So they're learning, they're working with the vendor. You do things to the hardware. The vendor tells you that should have worked. It doesn't work, right? So you do things differently. And there's this that you're iterating over what the story was that said configure that piece of hardware. So you almost have to have that. I mean, that's like the smallest story that I could personally think up, is to say go and configure that piece of hardware, but that could take you like a week, and that story is humongous. So how can you break that down into like smaller pieces, or should you? And I'm okay with saying, hey, on some of these stories, we don't break them down that small because we just don't know. We call it a spike, and it's innovation work, it's research work.
It's a spike to figure out how to do it, and then now let's make a process for the next one that we can
do it faster.
Cookie cutter, yeah. But maybe it is. Maybe you've got this hardware and it's a network switch that talks to 100 devices, but you only need to figure out the first couple to know how to do the rest of the 100. So there might be, pieces of that configuration that could be broken down into multiple pieces. Or first of all, make these two devices talk to each other, then add the security layer. I've had to work with IPsec, and that's a pain.
Well, that's the same thing that I did with hardware when I did communications, and it's the same thing I do with software now. Is like you said, get it talking, then add encryption or authorization or whatever. Add each level as you go.
Yeah, that reminds me of the what was your example like last week or 2 weeks ago, Amos, on making a thin vertical slice of an application, and you didn't have. Oh, it was the coming soon page. So instead of having a login, the person's like, I can't imagine having an application that doesn't have a login. And Amos is like, well, just have a coming soon page, and you submit your email address or you sign up for an account, and that's your first story.
Oh, yeah. I said first story is registration. They're like, well, you can't register and then not have people be able to log in. And I said, yeah, you can. People do it all the time. Like, it's like, hey, register to be an alpha user. And they're registering, and all it says is thank you. And then tomorrow you can deliver the next piece. And it might be something tiny too, but just delivering that one thing.
You got to think outside of the box sometimes to come up with ways to split your stories like that.
All right, Craig. Well, I think Amos has officially gone over the edge with all his sniffing and coughing. So as promised, we have to end the show. So I think some of the parting words here are that you have to be willing with hardware and with some of these external dependencies to just let them go, not let them go in terms of not care about them, but send them off into the world with knowledge and with understanding that work is going to get done. It's going to come back, and you have to figure out the best way to deal with keeping track of where that is, and accept the fact that some of this maybe longer running hardware work or innovation work that you're doing is going to require a lot of research spikes, a lot of stories that are going to result in additional stories that help the team understand the work that they're going to have to do. Anytime you're doing this sort of innovation work, you're going to be doing a lot of stories that generate other stories, essentially.
Yeah.
That everybody has to understand that going into it.
I think that's how all of our work usually works.
Sometimes
every story generates other stories, I think.
They can. I mean, some things are really straightforward and there's not a lot of unknowns with it, but you do have innovation work where you have to go figure it out. And I tell teams all the time, okay, the outcome of this story is going to be more stories that explains to us or helps us understand we built it crappy one time. Now we're going to write stories to build it the right way the next time.
So the outcome of configuring this hardware the first time is a big piece of paper that we're going to make our next story that automates configuring it the second time.
Yeah, that's why I don't like burn down charts. They're not helpful because we're learning stuff and adding stories as we go. I think a burn up chart that shows your progress is much more useful. Okay, good. That I think should be the topic for the next show, and you and Tice can duke it out over
over that
Burn Out
particular
versus Burn Up.
topic. Yeah.
This week's hottest picks.
I'll go first this week, guys. I found a story, not a story, it's a blog post from a guy named Ed Finkler. He wrote a blog post about how to be a great developer, and he just goes through and gives a bunch of bullet-pointed examples of how you can be at least a better developer. I think there are a few good nuggets of information in there, so check out Ed's post. I've got the link in the show notes. All right, Amos, what are your picks this week?
First of all, I'm going to apologize because I didn't realize that I wasn't on mute, and I sniffled during your pick.
You sniffled.
So sorry.
You sniffled during the whole show.
I'm sorry.
Just
I
to
don't
be
even
fair.
realize it. So my pick is an article called "How to Sell TDD to X," so to anybody. And I just thought it was a really good article. It talks about it's got some links to the beginnings of TDD and some other stuff. I don't know. It's just a really good article. I think everybody should read it. It's really useful, and it's by Marcus Gartner. I hope I said that right. He's got the classic A, German A with the double dots over the top of it. So I think that's an A umlaut. So that's it. That's my only pick for the night.
Good picks, Amos. Craig, what have you have for us this week?
Ooh, wait. Good pick, Amos. It was just one.
Oh, wait.
Okay.
Good pick, Amos.
Thanks.
Craig, what do you have for
that
us?
was a quick feedback cycle.
Exactly.
Right
All right.
Example.
I've got an article by Jessica Kerr. Estimates in Our Brain. Talks a little bit about estimating, which we always like to talk about. And my second one is a very short article by James Copeline. That's called Two Heads Are Better Than One. It basically talks about pair programming and the history of it. And he was kind of involved with a lot of the people. Kent Beck, Ward Cunningham. I was involved in the
C2 project?
I don't
Was
think
it
so.
C2?
This says he was involved in the Hillside project, which I don't know if it was before or after that, but he was involved in design patterns. I know him back from a book he wrote called Advanced C++ Programming Styles in 1991. But he goes through the history of pair programming and traces it back to, I believe, at least 1972 or so. So actually, I've seen things that have taken it back even further, like to the 60s and maybe even the 50s. This is a nice little article, though. And since we were talking about data centers in the Arctic, it looks like I'm not the only one that actually found that while we were talking. There's an Ars Technica article talking about running a South Pole data center.
That must be one
Put that
hell.
in the show notes.
That must be one hell of a long internet cable.
Probably not much longer than the one to Australia, or the ones to Australia.
You could be right.
It shows them dragging cable in the picture on that article.
That was the one. By the way, that was the one I built. That's my personal data center down there.
Oh, that's very nice.
Yeah, thanks.
At least you know that nobody's going to break in. Like, you've got that security down.
You got to beat the penguins.
You've got physical security down pretty well.
Yeah.
Yeah.
Plant security we have covered. We have a bunch of penguin slappers.
All right, John, I've got to add a pick. Since you said picks the first time, I've got to add one.
I see.
Is that okay?
I will allow it.
All right. Thank you. Since Tice is in here, I'll get away with this. I just want to add the pick for Ruby Remote Conf is coming up soon. There will be a link in the show notes. I'm speaking at the conference, and the cool thing about it is you don't have to fly anywhere. I call it a conference from your armchair. So it's all online, and you can watch it. It's put on by Charles Maxwood of Ruby Rogues fame and DevChat.tv. So I'm looking forward to it, and it would be really neat if some of our listeners came.
My chair doesn't have any arms.
That's because you don't have any arms, John.
Hey, watch it.
Oh, no.
I'm typing with my toes. All right, guys, that's all we have time for today. Thank God, after all of my bad puns. Check out thisagilelife.com for our show notes and for all of our past episodes. Thanks for hanging in there with us, and thanks for listening, and keep living this agile life.
This Agile Life is brought to you by a community of Agile developers and coaches aspiring to spread the word about this groundbreaking approach to software development. Join us at thisagilelife.com/community.